x.
Already x.
Okay. So in the operator, we have to take a different eigenfunction psi I. This will be psi I, but lambda remains same. So this lambda is known as degenerate. For each eigenfunction corresponds to same eigenvalue. So write. After that you write O cap psi I x is equal to lambda into psi I x. So this lambda is known as degenerate. That means the operator will be same. If the eigenfunction is psi 1, this gives you lambda 1 psi 1 into x. If you take psi 2x, Samya, what will be lambda? This is lambda, not lambda 1. So what will be here? Samya? Samya Ranjan? Hello? Pragya?
Yes, sir.
So if for degenerate eigenvalue, what I have written? O cap psi 1 x is equal to lambda into psi 1.
Lambda psi.
So if the eigenfunction will be psi 2, so what will be the eigenvalue? Same lambda.
Yes, sir.
Okay. So if you take the eigenfunction is psi 3, so the eigenvalue remains same. That is lambda psi 3x and so on. So now for each function lambda remains same. So this lambda is known as degenerate eigenvalue. Okay.
Yes,
Understood?
sir. Yes, sir.
So next write non-degenerate eigenvalue. Non-degenerate eigenvalue. Non-degenerate eigenvalue. So this is nothing. For each eigenfunction corresponds to different eigenvalue. All of you write. For each eigenfunction corresponds to different eigenvalues. Okay. So here what will happen? O cap psi I x is equal to lambda I psi I x. That means each eigenfunction, if you take psi 1 x, it will be lambda 1 psi 1 x. If you take psi 2 x, it is lambda 2. So if eigenfunction changes, then lambda also changes. Psi 3x is equal to lambda 3 psi 3x and so on. So this you see here the eigenvalues are different. So these different eigenvalues are called non-degenerate eigenvalue. Understood? Previous case lambda was same, but here lambda changes. Lambda 1, lambda 2, lambda 3. So it is known as non-degenerate eigenvalue. Okay? Vikas
Yes,
Kumar.
sir.
Vikas
Yes, sir.
Kumar. Are you writing or not?
ये लिख रहे हैं सर, लेकिन नॉन डिजेनरेट का डेफिनेशन थोड़ा छूट गया है सर.
लिखो for each eigenfunction corresponds to different eigenvalues. For each eigenfunction corresponds to different eigenvalue. Okay. So after that, this is O cap psi I is equal to lambda I. Lambda I means
Yes,
for
sir.
eigenfunction psi 1, this becomes lambda 1. Psi 2, lambda 2. Psi 3, lambda 3. And so on. Okay. Next write
Yes, sir.
orthogonal. Next write what is orthogonal wave function. orthogonal wave function. Leko, two wave function psi 1 and psi 2 are said to be orthogonal if
Sir, out three.
psi 2, two wave function psi 1 and psi 2 are said to be orthogonal if psi 2 star x into psi 1 x dx is equal to 0. Two wave function psi 1 and psi 2 are said to be orthogonal if psi 2 star into psi 1 x dx is equal to 0. So, what is psi 2 star? Who can say? Sonila. Sonila, what is psi 2 star? Who can say?
Sir, complex conjugate.
Complex kete thara kohabo? Huh? Psi 2 star means it is the complex conjugate of psi 2. Suppose on your problem, two wave functions are given psi 1 and psi 2. Prove that the wave functions are orthogonal. Then you take the complex conjugate of the psi 2, you multiply with the psi 1, you take the integration, the right hand side is equal to 0, then only we can say it is orthogonal. Okay? So next write normalized wave function. What is normalized wave function? Right. A wave function is said to be normalized if psi x mod square dx is equal to
Sir,
1.
normalized.
If integration, this is integration minus infinity to plus infinity, psi x mod square dx is equal to 1. How you have to find psi x mod square? Who can say? Gupteswar. What is psi x mod square? What is psi mod square? Who can say?
Sir,
Ruturaj?
psi star into psi.
Psi star into psi. Look here. So psi is given. You can determine psi star means complex conjugate. If you multiply, then we can find this is psi mod square. Okay. So if psi mod square dx is equal to 1, it is known as normalized. Okay. Next write orthonormal. Orthonormal wave function. Eh? Clearly. Orthonormal wave function. So orthonormal means it is a wave function which is both orthogonal and normalized. Right. If a wave function is both orthogonal, and normalized, if a wave function is both orthogonal and normalized, then that is called orthonormal wave function. That is called orthonormal wave function. Next is expectation value. Next write expectation. EXPECTATION. Expectation value means this is the symbol of the average. If A be the physical quantity, if you put this bracket, it is denoted as expectation value. So right, the average value of all measured physical quantity, the average value of all measured physical quantity is called expectation value.
Sir, all major.
The average value of all measured physical quantity is called expectation value. Okay,
सर उसका सिंबल कैसा था?
the average value of all measured physical quantity, that means we have to find the average value. So that average value is termed as expectation value. If A is a physical quantity, the expectation value, look here, the formula is minus infinity plus infinity psi star A cap psi into dV divided by psi star psi into dV. So this is the formula for expectation value. If you want to determine the expectation value of physical quantities A, so it will be integration minus infinity plus infinity psi star A cap psi into dV divided by integration minus infinity plus infinity psi star into psi into dV. What is your A cap here? Who can say?
Unit vector.
A cap with the operator. Okay. So, as you know, the denominator gives you 1. Why 1? Because if you multiply psi star with psi, we can find psi mod square. What is psi mod square integration? That is 1. Just I told you, in case of a normalized wave function, this value is equal to 1. Okay. So we can write, so far as your syllabus is concerned, so it will be asked for normalized wave function. We can write for normalized, understood or not? For normalized wave function, Pragya, bujheuchi?
Yes, sir. Sir,
For
for
normalized,
normalized wave function,
so far as your syllabus is concerned, the wave function should be normalized. If the wave function will be normalized, what will be your denominator? The denominator will be 1, because if you multiply psi star with psi integration, that gives you 1. For normalized wave function, the expectation value A is equal to integration minus infinity to plus infinity psi star A cap psi into dV. So you have to remember the formula. Psi star A cap psi into dV. Okay. Suppose
sir, authority ଏଇଟା କଣ?
ଏଇଟା ହେଲା expectation value formula. Numerator, this is the denominator. But in case of normalized wave function, the denominator value is equal to 1, because if you multiply psi star with psi, that gives you psi mod square. What is psi mod square? Psi mod square integration is equal to 1 for normalized wave function. Okay. Okay.
Yes, sir.
So,
Yes, sir.
for normalized wave function, the operator A, the physical quantity A, or we can say the expectation value is equal to integration psi star A cap psi into dV. Suppose we can determine the expectation value of position coordinate. What is the position coordinate? X. Array position coordinate means the Cartesian coordinate system.
Yes, sir.
Last class
Yes,
I
yes,
told
sir.
you. Okay, we can take Cartesian coordinate as x, y, z. So what will be the expectation value of position coordinate? That means x expectation value is equal to integration psi star x cap psi into dx. So dv means here dv means what? Dx into dy into dz. Okay. Since we are getting x, so integrand will be dx. Okay. So now what is x cap operator? Who can say? What is the x cap operator? What is the x cap operator? Pragya?
Yes,
Uh,
sir.
what is it? I have taken the expectation value of x. So how can I write? Integration psi star x means I have to put a cap x cap. X cap means operator of the x into psi into dx. What is x cap? What is the value of x cap?
X.
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 Very good. So you see your previous note. We have written x cap is equal to x, y cap is equal to y, z cap is equal to z. So x psi into dx. So to determine the expectation value of a physical quantity, the wave function must be given. So from that wave function, you find the complex conjugate. You multiply that complex conjugate with the operator, then again multiply with the wave function itself. If you integrate, the value gives you the expectation value of that quantity. Okay. So this is the formula for position coordinate. Again, if I want to find what is the expectation value of linear momentum, who can say? Linear momentum along x axis, I have written px. कौन लिखिबी को? Who can say? अरे केमती लिखिबी? Hello?
Integration minus infinity to infinity psi star p cap psi
Psi star. So px means px cap psi into dx. Then integration. What is the px cap?
Minus of I h cross d by del x.
Del by del x. Okay. So this is the formula. Since minus ih cross is constant, taking outside, this is integration psi star. What is the remaining term? Del by del x of psi into dx. So this is the formula for expectation value of linear momentum. Okay. So like this, so whatever the question you will ask, you have to remember the formula. We have to find the psi star, multiply with the operator, again multiply with the wave function. We have to find the integration. Okay. Next, write principle of superposition. Principle of superposition. So, okay. So this principle of superposition, lecture heading the law,
Yes, sir.
Yes, sir.
is also known as expansion theorem. It is also known as expansion theorem. It is not so difficult, easy thing. Okay. So you listen, what is the statement? Principle of superposition. Right. If psi 1, psi 2, write the statement. If psi 1, comma, psi 2 comma psi 3 comma 3 dot psi 1 psi 2 psi 3 are the wave functions of any system.
Are the wave function?
psi 1 psi 2 कौन wave functions are the wave functions of any system then their linear combination their linear combination gives another their linear combination gives another state of the system another state of the system such that psi is equal to C1 psi 1 C2 psi 2 C3 psi 3 plus 3 dot. Okay. Ruturaj Lanka.
Yes, sir.
Read the statement.
If psi 1, psi 2, psi 3 are wave function of any system, then their linear combination gives another state of the system such that psi is equal to C1 psi 1 plus C2 psi 2 plus C3 psi 3.
Okay, very good. That means if we have to take, we have two system. We have two system. In one system, the different eigenfunctions or the wave functions are present. Okay. So if you determine what will be the resultant wave function in another state, this is state 1, this is system 2. So what will be the resultant? Your answer says your principle of superposition or expansion theorem said that the resultant is nothing C1 psi 1 plus C2 psi 2 like this, where C1, C2, C3 are known as probability amplitudes. You can write where C1, C2, C3 are known as probability amplitudes. Psi 1, psi 2, psi 3 are known as wave function or we can say eigenfunctions. Okay. So there is a relationship between probability and amplitude. So right. Probability of the system P is equal to C mod square. If amplitude is known to you, so probability is equal to square of the amplitude. C with the amplitude. Okay, समझ में आया?
Yes, sir.
Yes, sir.
So write on problem. Find the wave function of a system. Find the wave function of a system represented by eigenfunctions psi 1, comma psi 2, comma psi 3 having probabilities 1 by 2, 1 by 3, 1 by 6 respectively. Okay. Soumya,
Yes, sir. Yes, sir.
read the question.
Find the wave function of a system represented by Eisen's functions psi 1, psi 2, psi 3 having probabilities 1 by 2, 1 by 3, 1 by 6 respectively.
Okay. So what will be your answer? What are the informations given here? Who can say?
C and C1, C2, C3 and Psi1, Psi2, Psi3.
Huh? So we have to, you read the question, find the wave function of a system. That means we have to determine wave function of a system where in another state the eigenfunctions are psi 1, psi 2, psi 3. Having their probabilities, P1 is given 1 by 2, P2 is given 1 by 3, P3 is equal to 1 by 6. We have to determine the wave function psi. So you have to apply the principle of superposition. Psi is equal to C1 psi 1 plus C2 psi 2 plus C3 psi 3. So if probability is given, how you have to determine amplitude? Who can say?
Square root of probability.
Yes. So P1 is equal to 1 by 2. What will be C1? 1 by root 2. What will be C2?
1 by root 3.
What will be C3? C3 will be 1 by
Root 6.
root 6. Now, according to principle of superposition, the resultant wave function psi is equal to C1 psi 1, C2 psi 2 plus C3 psi 3. So now you put C1 is equal to 1 by root 2 psi 1, C2 is equal to 1 by root 3 psi 2, C3 is equal to 1 by root 6 psi 3. So this is your answer. Okay. So the
Yes, sir.
psi is equal to, these are the important problem. Not so difficult. Amplitude probability is given. We have to determine the amplitude, then the principle of superposition. Okay. Everybody understood?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. So next, another thing you write, energy expectation value. Energy expectation value, EXPE CTATION. Energy expectation value. So you may ask questions, sir. Already we discussed expectation value of any physical quantity. Am I audible?
Yes, sir.
Yes.
So another formula
Yes,
you
sir.
remember, the energy expectation value, E for energy is equal to P1 E1 P2 E2 P3 E3 3 dot. Okay. So where P1, P2, P3 are known as probabilities, where P1, P2, P3 are known as probabilities, Lities. Okay, E1, E2, E3 are known as energy eigenvalue. Energy eigenvalue. Okay. So if the energy eigenvalues are given, probabilities are given, the energy expectation value formula is P1 E1, P2 E2 plus P3 E3. Okay. So you have to apply this formula. Okay.
Yes,
So
sir.
I told you. Okay. So next, another question you write. The probability of finding the particle in between x1 and x2 is P is
Finding
equal
the
to
particle.
probability of finding the particle in between x1 and x2 is P is equal to integration x1 to x2 psi x mod square into dx. Okay. So I told you two formula for probability. Probability is equal to square of the amplitude. And suppose this is the lower limit is x1, higher limit is x2. So one particle is present here. Okay. So Pragya went to find the particle. Pragya,
Yes, sir.
have you seen the well? Well का मतलब क्या है? WELL. Well का मतलब? हाँ?
सर बेटर
हाँ?
जो सर
अरे
बेटर जो था ना वो
हाँ well ମାନେ ତ well better ଆଉ ଗୋଟେ well ମାନେ ନଥାଏ ଯୋଉଠି ପାଣି ଥାଏ ତାକୁ ଓଡ଼ିଆରେ କଣ କହନ୍ତି?
सर
ଏଟା
कुआ
ହୁଇଲ ସାର୍ ଡବ୍ଲୁ କୁଅ
हाँ କୂଅ.
କୁଅ କଣ ଯେ WHEELL ସେଇଟା ଥାଏ ହୁଇଲ
Okay. So suppose you might have seen in village area. Okay. Nowadays it is not seen, I think.
सर
So
अच्छी
this is a well. Inside the well, one frog is staying. Okay.
yes
So
sir
suppose you entered inside the well to find the frog. Okay. So there is a constraint. The well is in between x1 to x2. So it is not easy to catch the frog. When frog watches you, the frog will hide. Am I right? So what
Yes,
is
sir.
the probability? The probability of finding the frog inside the well is P is equal to x1 to x2 psi x mod square dx. So you apply this formula to find the particle, probability of finding the particle in between x1 to x2. So on your numerical, we have to discuss later. Suppose the particle is confined. Okay. For that particle, the wave function must be defined. If the wave function is given, then you apply this formula. And remember, psi x mod means psi star into psi. If there is no complex number, all are real, then simply you take the square. If there is complex number, then you change the sign of the imaginary part. Okay. So this is all about the probability of finding the particle. This is, I have completed the first unit of this module 5, and the second unit is application part, right? Application of quantum physics. So we studied the quantum physics. Now what is the application? So earlier we have 3 to 4 applications, but for the revised, as per the revised syllabus, there are only 2 applications. Okay. The first application is free particle. So just you write, then I shall stop here. Free particle. Parichay, are you there? Parichay? Parichay is not there. Because
sir.
what do you mean by free particle? What is the literary meaning of free particle?
सर उसमें कोई फोर्स वगैरह नहीं लग रहा है.
Very good. You are absolutely correct. A particle is said to be free when no external force is acting upon it. Suppose now all of you are staying with your family members. I cannot say you are free. But when you will come to the college campus, you become free. Why? When you are at with your family members, you are constrained by your family members. Your parents, your brothers, your sisters will say, don't do this work, don't do that work, don't use mobile so many times. That means, and you engage yourself with study. But in college campus, you are doing as per your wish. Okay. As per your time, you are coming to the class, you are not coming to the class, not attending the lab class. Okay. You are moving here and there. So you become free. Okay. So we can say, you all of you note down, a particle is said to be free. A particle is said to be free when no external force is acting upon it. A particle is said to be free when no external force is acting. No external force is acting upon it. समझ में आया?
Yes.
गुप्तेश सर.
Yes.
गुप्तेश सर. Abhinandan.
Yes, sir.
Yes, sir.
Are you writing or not?
Yes, sir.
Those who are not writing, no mark will be given. Honestly, I am telling. Okay. So tomorrow, serial number 1 to 10. Listen carefully. Tomorrow at class time, serial number 1 to 10. Everybody, you have to open your camera. I shall check the copy. Okay.
Yes, sir.
Yes, sir.
Serial number 1 to 10. Next day 11 to 20 like this. Okay. Okay.
Okay,
Yes, sir.
sir.
So today,
Yes,
today you have what exam? Internal exam?
Math.
Mathematics.
Maths.
Mathematics. Okay. How many questions are there?
10 questions.
10.
10 questions.
10, sir.
Huh?
10 questions.
10
10.
questions, sir.
Okay. And the mark is
30 mark.
30.
30 marks. All are MCQ based or कुछ writing things?
MCQ, sir.
MCQ.
MCQ.
Okay. Okay. ठीक है. So okay, and we have left only the surprise test one. So since the name itself means surprise, so the date will not be announced. So that may be